Hello, everyone. My name is Max. I'm a machine learning engineer at deepsense.ai. And today I'll show you how to build a ChatGPT connector using FastMCP, test it with MCPInspector, and wire OAuth with outcode plus PKCE without any further headaches. So we're going to keep it very practical. The moving parts, the end-to-end flow, the failure cases, and the lessons I wish I would had on the day one when I started. So quick agenda. First, why connectors matter. Then the tools we will use. Next, we build the simple server, add OAuth, then talk about the pitfalls and wrap it all up with the Q&A session. So first, why do we even need connectors? LLMs are powerful, but they are super blind to our private systems by default. Yeah, as you can see, there are some questions even the best LLMs won't answer. Connectors can safely bridge ChatGPT to apps like Google Drive or GitHub, so you can search files, pull live data, reference it, and use it all right directly in the ChatGPT. So what are connectors? In one line, a connector is a secure bridge, so ChatGPT can use real tools, real data from our apps. Like we can think about searching a folder, querying a database, or sending an email without leaving ChatGPT. So after we connect it, ChatGPT is much more powerful than without that. So first, let's wrap it up. First, they can integrate real data directly in the chat. Second, then they can provide actions like searching files, sending emails, and querying DB. And third, they bridge LLM and service API via standardized calls. So there might be some confusion between what connectors, ChatGPT connectors, MCP servers, and LLM tools actually are. So first of all, connectors are used only within ChatGPT, and they are pre-built integrations that let us securely reach our apps within ChatGPT. MCP server, on the other way, is a server that exposes capabilities over the model context protocol. And the tool is just a single callable action that an LLM can invoke. We can picture it ourselves much better looking at this diagram. So as you can see, we can have many tools used by many LLMs, but within our ChatGPT connector context, we can use only one MCP server that gives the ChatGPT all of the capabilities of the before mentioned LLMs and tools. So what are actually the kinds of connectors we can use within ChatGPT? There are three main modes to know. The chat connectors that are simple on-demand actions during a normal conversation with ChatGPT. Second one is synced connectors. And what is the main point of them is that they use pre-indexed sources, like Google Drive is the best example, for low latency retrieval. And third, the most interesting of them all are the deep research connectors that are used for long form browsing, long form research for ChatGPT, and they use search and fetch methods. And the most important of it is that they produce cited results. So we actually get a reference to a particular passage of the text that is the basis of an output that ChatGPT will produce us. We can see it very good on this picture of a sample connector. That there are three main points that constitute the anatomy of a ChatGPT connector. First, the identity, which is basically the name that we identify the connector about. What is important is that admins enable each connector for each user. So each user can authorize themselves within the connector with their own account. Second one are the capabilities. So the modes that we've just mentioned that the connector can be used with. And third are the endpoint and all the details that our connector will use. So let's walk through the flow and see where OAuth and the bear token actually fit. So first, user enables the connector and asks a question. Then the model decides to call a tool via the connector. And third, our hosted MCP routes the call to your FastMCP server that we will actually build in a second, and the server will return results. So we can very clearly see it on this diagram. So we start from users enabling the connector, which are represented by the numbers 1, 2, and 3 on the sequence diagram, and at the same time the OAuth consent occurs. So when we connect the connector, we actually perform the whole first part of the OAuth flow. Secondly, after the connector is actually up and running, when we ask ChatGPT to utilize our connector, then we see the second part represented by the numbers 10 and 11 being performed. So there is a tool call that is sent to the connector with a bear token provided. So our MCP server actually knows that we are the users with the right permissions. And after all of that, our MCP server returns data to our connector, and via the connector, ChatGPT returns the result to the end users. So now I'm gonna mention two very helpful tools that we gonna use to build our ChatGPT connector. So the first one is called FastMCP, which is a golden standard. It's a Python framework for building MCP servers quickly. It allows us to decorate functions, run the server, and get it up and running very quickly. It handles the protocol details, and we will use it to actually get our server running and to expose search and fetch methods for the deep research connector we are going to build in a second. So looking at FastMCP documentations, the important stuff that we might be interested in, we can find in the overview tab and in the core components. So in these two sections, we are gonna cover 90% of the use cases we gonna use it for, and the rest 10 will be covered by the OAuth tab, where we can find pre-built integrations with known providers such as Azure or Google, but we can also find their tools for even our custom custom identity server if we want to build one. And moving on to the second one, the second tool I mentioned, which is MCPInspector. And MCPInspector is the graphical interface for testing our MCP server. First of all, to get it actually running, we have to provide the URL, select proper transport type, which will be probably 90% of the times streamable HTTP, which is the golden industry standard right now. And after we connect, we can see a top bar with various cool kinds that we can utilize it for. The most helpful are the tools tab, where we can test and list the tools of our MCP server, and the OAuth tab, where we can find tools to help us get OAuth flow in our MCP server running. So right now, we're gonna build our ChatGPT connector end-to-end. First, we're gonna build the server. Then we're gonna implement search and fetch methods. And at the very end, implement the OAuth flow, which is a requirement to get a connector properly connected to ChatGPT. And we'll have a brief summary of deployment options of our server. So, starting off, what you can see in the picture is a tiny MCP server. Just import FastMCP, create the app, decorate a function, and running it. But actually, for ChatGPT connectors, Hello World isn't enough. What we see in here isn't enough to be utilized by ChatGPT. When we want to create a custom connector, we must implement the search and fetch tools. So the model can actually find and retrieve content. So for search, we need to keep the schema exact. So the names, the params, and the return type. Then we need to document it clearly. So the description is what the model reads, not the docstring. In FastMCP, docstrings are ignored. So as mentioned, it's not Pydantic AI. The docstrings will be ignored. Then moving on to our fetch method, it's very similar. We need to adhere to the schema, and we need to properly document the methods. After implementing such two tools, our MCP server will be almost ready to turn into a ChatGPT connector after we implement proper OAuth flow. So right now, let's add OAuth. We'll look at three options that FastMCP provides. So option one, which is RemoteAuthProvider. This is the option that uses dynamic client registration. So we're gonna use it when our provider supports DCR. The second option is OAuthProxy that adapts MCP DCR expectations to traditional OAuth apps like GitHub or Google. And the third one is OIDCProxy, which is very similar to OAuthProxy, but it also auto-discovers endpoints from the provider's OIDC config. So starting off, as you can remember on one of our first points introduced, we presented a sequence diagram. So while talking about OAuth flow in MCP servers, we are looking at the first part of our sequence diagram where we enable the connector, we start the authentication, we go through OAuth consent screen, and then the tokens are exchanged. So RemoteAuthProvider, a few more words about that. So once again, it uses dynamic client registration. So what is important about that is that it exposes discovery metadata, so MCP clients learn how to authenticate. Second, OAuthProxy adapts DCR expectations to traditional OAuth apps. What is also worth mentioning is that many known providers, such as Google, such as Azure, GitHub, they don't provide DCR. So FastMCP has a lot of inbuilt classes for main identity providers. So it's going to cover most of your cases, but for more complex ones, like, for example, Salesforce, you're going to need to use the base classes to implement it yourself. And the third one, OIDCProxy. As mentioned, very similar to OAuthProxy, but it also has auto discovery of the authentication endpoints. And after we've chosen on our method for authentication, we just need to pass it in the auth parameter of our FastMCP server, and we are ready to go. But how do we know if we are actually ready to go without trying and hitting the wall multiple times? Once again, we're gonna go back to our friend MCPInspector. So let's go to the authentication tab of our MCPInspector, where we can see how the whole flow will actually work. So first of all, we have three options, but today we're gonna use the guided authentication flow. So first of all, we have to initiate the discovery. So these steps, the first three steps, will tell the client how to actually authenticate with our server. Then we need to trigger the authentication. So as we can see, the first part, which is initiating the discovery, is performed. Then we proceed to request authorization. So request authorization is to start the OAuth consent screen where we log in with our Gmail or Azure account with our provider. So on the diagram, we see it as the third part when the request actually comes from our MCP server to the provider. And then we're gonna have to exchange the outcode for a token and finish the whole authentication flow. So we exchange the token and we finish the flow. And after we do all that, then the MCPInspector will show us the green light, which means that the whole flow works correctly. So the only thing left to do is to deploy our server. And regarding the deployment, we have to remember about one key point, which is that we can deploy anywhere that is publicly reachable. So it can be Cloud Run, which provides public endpoints out of the box. We just need to enable the option to allow external connections. We can also use AWS Lambdas, but we're gonna need API Gateway to set the server to be publicly accessible, or we can use Cloudflare Workers. But from my experience, I cannot really recommend that options for Python servers, because the support for Python on Cloudflare is in very early adoption, so it's mostly recommended for JavaScript servers. So now the only thing which is left is to connect our server into ChatGPT. So first, what we see when we go to ChatGPT is that after inserting our data, we see that search and fetch options, search and fetch tools have been properly discovered. So that means we are doing good, and the methods, the tools that we implemented have proper annotations and proper schema. So we go on, we try to connect, and let's go back again to our sequence diagram. We are right now starting the whole OAuth flow. So right now we are at number 1, and after clicking to continue to my new connector, the number 2 and 3 will happen, and we gonna receive the consent screen from the OAuth provider. After we go through that whole flow and log in onto our account via our consent screen, our connector is up and running. And we can actually select it in clicking on the plus button, and we see that our connector is accessible and we can actually use it in our chat. So now the fun part, the things that actually can go wrong. So one of the very common problems that you can encounter is that you miss PKCE. So if the code exchange fails, that can happen. And one of the quick solutions is that we need to double check whether PKCE is actually enabled in both client and the identity provider, because it sometimes happens that there is not, and you can be stuck on that one, hitting a wall. Then you can have issues with redirect URL rewrites. So sometimes proxies or load balancers tweak callbacks, and to sort it out, we have to pin the exact redirect URL and, of course, trust proxy headers. Then there might be issues with streaming cutoff or buffers. So to sort it out, we need to check the timeouts and flash behavior on our server. As the fourth one is actually the most common one, search fetch not discovered. So when we connect when we try to connect our connector to ChatGPT, the methods can possibly not be discovered properly, and there's a plethora of reasons why such thing can happen. It can be tool names, so we can misspelled or mistaken our tool names. We can have wrong schema, wrong parameters, wrong description of our tools, wrong metadata, no annotations. So basically what it says is that we have some kind of issue that with our tools that we need to fix. And what is the issue is actually up to you to discover. And lastly, we can have issues with wrong scope or our audience. So we have to make sure that our scopes match the API that we call, and the audience match our token verifier. So the lessons we've learned. First of all, docs are not a source of truth, especially in FastMCP, but I think it can be a rule in all very new, very rapidly changing technologies. So they drift a lot, and we need to treat code and the client behavior as the source of truth, because I've actually experienced that the docs can change day by day or be outdated oftentimes. But who we can count on is OpenAI, because they asked, they always provided good insights, and the knowledge is really, really broad. Just needs to be very recent. Going on further, what is very important is to properly document our tools. So clear names, clear annotations, clear descriptions, and strictly adhering to the schema is the key for the tools to be better understood and better used by the model. Next, know OAuth. Understanding PKCE, scopes, audiences, and redirects is critical, especially knowing that OAuth is a necessary requirement to have a ChatGPT connector up and running. And as the last point, you have to expect the changes. So once again, the ecosystem moves very fast, and you need to plan for updates. And going back to the question that we asked at the very beginning. So why do we even need connectors? So after we developed our connector, we see that we can use the connector to retrieve our internal data that ChatGPT wouldn't be able to access without that. So thank you everyone for coming and listening. I was very happy to share that knowledge, my experiences, my lessons, and my failures with you.